actually access it and submit a couple of scripts just for demonstration. I'm Bandelis Georgiadis. I'm an associate research scientist at C. I'm also the task leader for training and development. So I organized the event today. Oh, it's going fine. And let's start with what high performance computing is. Any guesses? Yanni, you should know, it's your slide. So what we commonly refer to high performance computing is the use of supercomputers to solve complex computational tasks. Supercomputers have not always been as we see them today. For example, in the 1940s, we had ENIAC, which was one of the first computers, but because of the time, it was effectively a supercomputer. It was huge, you needed a room to be housed in. It was very expensive to buy and very expensive to operate. And as technology moves on in the 1970s, we have stuff like Cray 1, which was one of the first commercial supercomputers. And one of the most successful as well. There was a few thousand were sold. There were much more computers in houses then, but supercomputers were still needed for specialized tasks, and is when the notion of parallelism started getting used. It was also the first to implement vector processing, which speeds up computation a lot, as we'll kind of see later. Later in the 1990s and early 2000s, we have started to see supercomputers that we understand them today, which is supercomputers designed using commodity hardware. Parallelism has been implemented as we understand it today with distributed and shared memory, message passing, splitting the jobs into many tasks over many different CPUs. And later on in the past decade, we have the dawn of heterogeneous supercomputers, which is we have many sockets per node, co-processors. So we have nodes with CPUs, GPUs, TPUs, etc. And ARM, x86, x64. So multiple architectures within the same system. Here we see Lumi. It's a good example. It has 360,000 cores and 144 million GPU cores. Performance of such systems is measured in flops, that is floating point operations per second. And there's an organization that tracks the performance of all the supercomputers in the world. It's called Top 500, and they publish a list twice per year and ranks the top 500 HPC systems in terms of performance. There you can see it's almost linear over the past 30 years. And if you see here, we now reach the exaflop range, which is 10 to the power 18 flops per second. And Frontier is the first system that passed the system and went offline earlier this year. Of course, in Cyprus, we don't have systems that large. You've seen earlier today Cyclone, which is really the most performant system in Cyprus and very competitive across the region. It's hosted here at the Cyprus Institute. You have both CPU and GPU nodes. And there's a different combination of clusters with various architectures, some for specific tasks, other for general usage. First and foremost, we have the Cyclone cluster. It's equipped with 40-core CPU nodes. There's 16 nodes with 4 NVIDIA V100 GPUs each. And each node has two 20-core Intel Xeon CPUs, 192 gigabytes of memory per node. We also have clusters based on the EPIC architecture. The one you're seeing here, 8 times 128 core CPU nodes is the Rome cluster. There's also another one, the Milan cluster, which is dedicated to climate science. I think that's not accessible by people outside the institute. You have the Cyclamen cluster of P100 GPUs, and also have the Cytera cluster, which is the old system we used to have here. It's not 98 nodes anymore, but there's still some operational. The nice thing about here is that Cyclone is open to access to all of you if you want. And there's two ways you can do that. You can either apply for preparatory access. If you go on the HPC facilities website, you can find more information about that. Preparatory access is meant for projects where basically you either port your code, you either scale up your code, or you develop it from scratch. This, we can also offer some assistance with that. And they undergo a light technical review. So just don't apply to mine Bitcoin and you're probably going to get accepted. There's an upper limit of 20,000 hours of CPU core hours and 1,000 GPU hours on this access route. There's also the production access route. That's intended when you have your code, everything is ready, and you want to, it's production ready basically, where you just need a lot of processing power to finish your project. This open, I think, is twice per year, Yanni. Production access. Yeah, they're open twice per year. There's a much higher compute resource available. You can get up to 150,000 CPU hours and 35,000 GPU hours, or some combination of the above. It's a much more rigorous technical review that's going for this kind of access. And yeah, then you need to submit reports on how you used it, how you utilized it. It's much more intense, but it's available to you as well. So I don't know, how many of you have used Cyclone before or used any HPC system before? Okay, so you're not all gonna get bored. As with almost all the HPC systems, Cyclone uses Linux. Is everybody familiar with Linux here? Okay, excellent. You access it with the terminal. There's no graphical interface. Basically, you use the terminal and open a bash shell, and then you write the commands there. Don't worry though, it's not as awful as it sounds. There's a lot of graphical interfaces that you can use to assist you. I use VS Code a lot, as a bunch of very useful plugins. For Windows, you can use Mobax Xterm SSH clients, FileZilla to access your data. So there are tools to help you. It's not just a terminal. To access it, use SSH. Basically, it's a secure shell you use over the network. If you're using Linux or Mac OS, you can use that straight from the terminal. If you're using Windows, you can use either PuTTY, Mobax term. It depends on what you like. So let's use that to access Cyclone. So if you open your preferred SSH client and access Cyclone, our engineers are here to help you if you want any help with it. Terminal, yeah. SSH, your username so at front02.hpcf.cyi. Everybody okay? Are the people online okay with accessing? But there's somebody that's monitoring the chat continuously. If you have any problems, please let us know there for the people online. Είσαι ενωμένος με το... Βάλες password, σημαίνει βάλες κώδικο στο πίσω. Δεν μπορούμε να σε βοηθήσουμε. Ah. Όχι, Gina, απλώς λες. Is everybody online connected? Is everybody connected? Yes. Oh, passphrase. Βλέπετε τα μαζί, ναι. For the people online, give us 2 more minutes. There's some technical problems here. Yeah. Okay, now that's everybody connected, shall we continue? When you connect on Cyclone, you'll see there that you're connected on front O2. That's called the front node of the HPC system. And basically, you connect to the front node and everything else is connected and controlled by that front node. Uh, Everything is connected as we saw before, the two with InfiniBand. The Computer Network Communication Standard is used in almost all of the high performance computing systems on the world. It's very high throughput and very low latency, so you understand when you connect to the front node, you should never ever run any compute task on the front node, because then every other user connected on the HPC will have problems with their compute tasks. When you connect to the front nodes, from there, there's another utility called Slurm, or Simple Linux utility for research management. It's a workload manager, and it's designed for Linux clusters of all sizes. So from 2 nodes to, say, stuff like Lumi, they run Slurm. When you go there, there's several commands you can use to either check the status of the cluster or submit jobs. Let's start with the simplest one. Run this one, sinfo, just to view all the unavailable partitions on the HP system of the Cyprus Institute. So you should see something like that. You see all the different partitions or clusters listed on the left. Have the Milan, we talked earlier about the climate cluster, Rome, the Alter AMD, Epic, Skylake, Nehalem is the old Cytera, CPU and GPU are Cyclone. And from there, you also have the state of these clusters: drain, idle, allocated, reserved, mix, etc. Don't really care about this stuff, but when you see all of them in a drain or down state, means there's something wrong, contact support. Also, there's the SQ command. With this command, it will report the state of running and pending jobs. So if you run it, you will see all the jobs that the users have either running or waiting to run at the moment. In order to allocate resources for you for a job in real time, you can use the salloc command. This will open a live shell for you. And in order to do that, there's a number of parameters you need to specify for Slurm to allocate resources to you. I'm going to suggest running salloc-h. It will show you all the available parameters for this command. As you see, it's a lot. You don't need to define all of them. That or double-help after in terminal command will provide information on built-in commands. So it's like a short manual for the command. In order to get a job now, these are the parameters we will need to specify. Account name. In your case now, account name is Edu18. That's the reservation made for you. Reservation is EuroCC-CPU. And for the rest, that was meant to be an exercise, but try that. Allocate a live shell for you, say 1 minute, not 10 minutes on one node, get one CPU and see how that looks. Now, this will allocate the resources you ask for the time you ask on a live shell. So it will basically, yeah, SSH to the node on the cluster, and there you can run compute jobs. What I use as allo is when I need to write the code, not actually do any compute task, just developing code. Sometimes it's useful to have a live shell on the cluster. Just as a reference, the maximum time you can ask is 24 hours. You can ask for more. Time is on minutes there. If you ask for hours, then it's hours up. Minutes. No. Oh, yeah. Semicolon. EuroCC. We reserved some nodes for you, so no, you have available resources. It's not gonna work after 5, so don't try to use it. Is everybody okay with the SLO command? Okay, now you're in a live shell on a node on the CPU cluster. You have one core at your disposal for 1 minute. When you go on a node, there's not much libraries or you can use there. So the way that HPC systems work most of the times, you have what's called modules. So there's a bunch of libraries or packages or compiled code in modules. And if you want to use that, then you need to load it. If you use this command, module avail, it will list all the available modules on the cluster you're connected on. Probably they're not sleeping and we're waiting for it to wake up. So if you're stuck on waiting for allocation of resources, it means, so to save power, they turn off some nodes where they're not in use. So you might have been connected to a node that was turned off and waiting for it to switch back on. It takes 4 or 5 minutes. Because we didn't. Oh, yeah. No. Hmm? Ah, look at slow. Nice. Okay, has everybody seen the available modules? Yes. Another way to search for a specific module is use the spider. So module spider, let's say module spider, let's say Python, or and it will show you all the available Python modules on there. You will see a bunch. There's different versions of Python with different pre-installed packages. And now to load the module, basically do module load and the name of the package. So let's load Python. This is a slightly different way I search for modules because when you do the spider, it gives you also all the description if you know exactly what you're looking for. You can list all the packages with the avail and then pipe that into a grep command, which does string matching. So if you grep with Python with capital P, it will show you all the available Python modules on Cyclone. Okay, and now load the one that we have there, SciPy bundle, because that has a few other useful packages in pre-installed, like NumPy. Copy and paste it from the list because well, this is not the only way to use this kind of programming languages. Conda and Py environments are quite popular in these kind of systems. But especially if you're using Conda, be a bit careful, don't create a lot of virtual environments because it creates a lot of data, a lot of small files in your home directory, and you have a limit on how many files we're allowed to store in a home directory. And most of the times when you go and update or install something, you will get a quote error. That's none available. Is everybody okay with this until now? I mean, for Python, as I said, you can use PyEnv environments or Conda. Just be a bit careful, don't create a lot of environments because you're going to run out of space. Also, I'm sure all of you have found a lot of code in GitHub, random GitHub repositories in the internet, and you're wondering how to put it on the cluster. You can clone GitHub repos using the git clone command and then followed by the URL of that GitHub. You can go ahead and clone the Git we created for today's event. I emailed you the link this morning, so you don't have to copy it manually, just copy paste. And clone it into your home directory and navigate into it. Has anybody not gotten the email? Maybe look in your junk folder as well. Ναι. Είναι τόσο απλό. Git, Git clone. Sorry, not GitHub clone, Git clone. I'll fix it. Okay, this is the command git clone. Has everybody cloned the repo? Είσαι ενωμένος με δυο... Δεν ξέρω. Τι σημαίνει το security violation του άλλο? Είναι από ένα... Αφού είσαι ενωμένος πάνω εδώ. Ah, okay, εντάξει, αν είσαι καλέξω, okay. Okay. Have you all downloaded the repo and navigated into it? Okay, now let's learn how to actually run scripts. As we said before, you can use a real-time shell using a salloc, which is not the recommended way to use an HPC. Or you can use the batch command to submit a batch script to Slurm. You can get more information about Slurm in this link. This will submit your script in a queue, and when the available resources, the resources that you request are available, it will run. So go into the intro HPC directory in the your training November 23 directory and list the contents of this directory and use the LL command for that. Basically, in the GitHub repo you just download, there's two folders going to the intro HPC one. You should be able to see these files. Are you? Okay, excellent. Does everybody know how to run Python script from terminal? Okay, run hello world then. And you should see hello world on your terminal. Yes? So your allocated live shell should have expired by now. Don't worry about that. We're gonna use the patch command from now on. PN στο intro HPC το directory. Και τρέξε το hello world. Ανοιχτά. Ναι, να πρέπει να το πω. Okay, we did. Now, let's run the first script. Print the pi_1.py script for the people that write Python. I'm sorry for this. It's done this way for a reason. So this is a Monte Carlo simulation to calculate pi. Basically generate a bunch of random numbers in the 0 to 1 range for x and y, and then you calculate the number of points that lie within 1 unit of distance from the origin. And that should be pi/4 ratio for all the points you generated. So for that, we import the random package, which is the base library for Python. This argparse is just for us to be able to give a terminal argument to the Python script, so we don't have to change this script every time. You specify n, which is the number of iterations for the Monte Carlo simulation. You instantiate two empty lists, then you loop for n number of times and populate them with random numbers. Then you loop again, calculate the distance from the origin for each XY pair. And then you loop again. And you add up all the points that are 1 unit of distance or less from the origin. Then you divide that by the total number of points, multiplied by 4, and that should be your estimation of pi. Again, sorry to the people who write Python. I know this is not correct. You'll see later why. Maybe run it for 1,000 iterations. Load the Python module again. In order to specify the number of iterations, you need to give the -n argument in the terminal to the Python script. So Python, the name of the script, and then the argument. Don't go more than 1,000 on the footnotes. Don't go more than 1,000. Not on the front node. Okay, so is everybody able to run it? Again, as we said, run it in a live shell is not the recommended way. The recommended way is to use sbatch and submit it so it gets into the queue, and when the results are available, it will run. When you When you use as batch, you also submit a script that contains all the parameters you need to use. And all these parameters are preceded with the hash as batch prefix. So because this is a batch script, all the batch scripts start with this. All the input arguments to as batch start with the hashtag as batch prefix. And basically you give the same arguments you use for as alloc. So job name is something you want. Job name is you give a name to your job so you know which it is in the queue. Don't really need it now because it takes half a second to run. Request one node. This is important. So -o, and you specify a file. This will redirect all the output from your script into this file, which usually is in the same directory that you submitted your job from. Then in task, you're gonna ask for one CPU, the -88 to 18, same as before. Partition CPU, reservation €CZ/CPU. And then we come to so this is the resources you ask. Then we come to the actual batch script. This is what the script will do after you get the resources. So you will load the Python module we loaded before with NumPy. It will print out something in the terminal, and then it will calculate I for a number of iterations that you specify from the terminal. So this is both a bash terminal and a bash terminal argument that will pass to bash script, and then that will pass it into the Python script. So now use this, run it again, but with hashbatch for 1,000 iterations and see what happens in the directory. Nice. Adriel? Hey, have you all submitted it? Now list the context of a directory to see if the .out file is created. And print the context of that. Also, you'll see that because in there we had the time command before running the Python script, it will also print out the runtime for your script. Nah. So is everybody okay? Is pi roughly correct? And it took about half a second to run. Okay. Now let's do that again, but do it for 1,000,000 iterations or 10 million iterations. Don't go more than 10 million because if you all do it, it will run out of memory. Let's queue. Very well, let's queue. And -b. Ada. Tamam, bilgilerini sunucuya. O buradan da SQ, ada SQ, minus U, minus U, for the usernames. Bak sistem hadi. Okay, is everybody okay with 1 million iterations? Of course, you run it for 1,000 times more. Okay, now print like pi_2 script, your terminal. So this is the same thing, but using numpy instead of for loops. So again, we use our parser to pass in the number of iterations. You populate the X and Y vectors with random numbers between 0 and 1 using the numpy random function. Calculate the distances in a vectorized way. And then replace distances that are larger than 1 with 0 and lower than 1 with 1 and sum them up and do the same calculation, calculate pi. So do the same thing with the pi_2 script. You can use submit job 2 for that. Run for 1,000 and 1,000,000 iterations. And compare the time taken for the 2 scripts and 2 number of iterations. Then name is budget. Job_view. Is everybody okay with that? Go online. So I also run it on my computer, and I got this for pi1. For 1,000 iterations, it was 90 milliseconds for version 1 and 300 milliseconds for version 2. For 1,000,000 iterations, 900 milliseconds for 1, 300 for 2. And for 10,000,000 iterations, 6.3 seconds for 1 and half a second for pi2. What do you think is happening here? So why is the first version faster to start with, but then it's much, much slower? There's no space. Yeah, why version 1 is faster to start with, but then gets much slower when we have more iterations. We run this. And this, yes, with NumPy for the same number of iterations. For the first few iterations, let's say for 1,000, the first version is faster. But then it gets much slower. Why? Kind of. Vectorization, NumPy is C.
Points, there should be a lot of overheads. Or the vectorization should be efficient.
So what do we understand from this? Yeah, that's always true, but all the fast things in Python are C on under the hood or Rust or the thing I want you to understand is that HPC is not the silver bullet. So if you have a computational problem, doesn't mean that you can always solve it with HPC. Sometimes if you just write better code or more optimized code, it's much better than trying to kill an ant with a bazooka. And that's very important because, as you heard before, HPC systems are very expensive to buy, maintain, operate. People that maintain them are expensive to pay. There's very high monetary cost on electricity, acquisition, blah, blah. There's limited resources of HPC. So sometimes you may submit a job and it takes 3 days to get resources to run. So it's not our personal computer to use whenever we want it. It's a shared facility and a lot of people want to go on it. And we also want to use these resources as efficiently as possible. So if your code can do the same thing in half an hour, why spend 20 hours running inefficient code and spending hundreds of euros in electricity per job? That was it from my side. If you have any questions, you should be able to log on to the HPC system, load modules, and submit jobs by now. It was the simplest Python job I could think of. I mean, all of us do some complicated things, so we couldn't go into too much detail in them. If you have any questions or the people online have any questions, please let us know. No? Okay, thank you very much. I will upload this on the events webpage. I think you will have the link to it. Stefanos will actually, I'm not sure when exactly, in the coming days. I think also the videos are going to be available there. Yeah, it's a free open access webpage so everybody can access it. Okay, guys, thank you very much. Next, we have Professor Yanis Koutsou on product programming.